Hi Algebra students, welcome to April. Today we're going to talk about graphing quadratics, and there's Dot the Math Cat to help us. Okay, so we've got three different forms: standard form, vertex form, and the new one is factored form. And we're going to talk about that after we review the first two. So standard form and vertex form we've talked about before. And we should have this in our notes. If you don't have this information in your notes, go ahead and pause the video and make sure that you've got this written down. Or you might want to write it down just as a refresher. So for standard form, it's that f of x equals ax squared plus bx plus c. Sometimes we write it as y equals. Sometimes right here we'll have y equals instead of f of x equals. Opens up when a is positive, opens down when a is negative. Vertex form is the same. Opens up if a is positive and down if a is negative. Differences come in finding the axis of symmetry. For standard form, it's this negative b over 2a. For vertex form, it's this x equals h. And remember that minus h is part of the vertex form formula. So if it's x minus 2, then we've got x equals 2 as our axis of symmetry. If it's x plus 2, it would be x equals negative 2 is our axis of symmetry. So the vertex in vertex form is really easy. It's just hk. And it's this here, hk. In standard form, we've got to use the x-coordinate, the negative b over 2a from the axis of symmetry, plug it into the formula to find the y. But the y-intercept is really easy. It's just the c value. In vertex form, we have to plug in 0 for x to find the y-intercept. Okay, so let's do one example with standard form. So copying down in your notes, example number 1, f of x equals negative x squared plus 4x plus 1. Okay, first thing, opens up or down. Hopefully you see that opens down. The a is negative 1. Axis of symmetry, negative b, so negative 4 over 2a. And that's going to simplify to x equals 2. Remember, that's an equation of a vertical line. So we don't just write 2, we write x equals 2. Find the vertex. So we're going to plug in that 2 for x to find the y-coordinate, because remember the vertex lives right on the axis of symmetry, so we just plug in the axis of symmetry value, and we get 2, 5. Okay, let's start drawing this. So we know the y-intercept also is 0, 1. If we plugged in 0, we'd get 1, but also we can just see that c value is 1. So we've got these points, 2, 5, and 0, 1. Now think about, there's going to be a point symmetric right over here on the other side of the axis of symmetry. There it is. It's going to be 4, 1, so we can even add that to our table. And then remember, this is going to be a parabola that opens down. So go ahead and draw that. And that's what you should have. Pause if you need to catch up on your notes. Okay, example number 2 is going to be in vertex form. So now we're going to go back to this vertex form, remembering that we've got this minus sign in the formula. And here we go. So we've got a being 2. We've got a plus 1. So remember, that means that this is essentially a minus negative 1. And then a minus 3. So our k value is going to be negative. And our h value is actually going to be negative, even though it's plus here, because that's like minus and negative 1. Okay, so let's go through what we know about this one. It definitely is going to open up because a is 2. The axis of symmetry is x equals negative 1. And the vertex, negative 1, negative 3. Y-intercept, just plugging in 0. So just be careful and do order of operations there. Here we've got 1 squared, so things are going to come out kind of nicely. And let's plot what we've got so far. There's my axis of symmetry, x equals negative 1. Vertex, negative 1, negative 3. Y-intercept, 0, negative 1. And then I've got a symmetric point over here on the other side. There we go. And drawing the parabola, this one opens up. Great. Okay, so that's kind of snoozy because we've done it before. Now we're going to go on to something that is not quite what we've talked about. Not totally new. But factored form you could write like this. And it's, remember, this is what we practiced yesterday, was factoring things. So now if we had a standard form, we could potentially write it in factored form. It's still going to open up and open down with the a value, depending on positive or negative. What's awesome here is we get to see the x-intercepts, because if we replace f of x with 0, we can see that the two things that will work here, if we've got a, whatever that is, a number, times something else, that means either this something or this something is 0. So either x minus m equals 0, which means that x equals m, or x minus n equals 0, which means that x equals n. Those are my x-intercepts. That's pretty useful for graphing. Let's look at an example here before we kind of fill in the rest of the stuff about factored form. So here we go. F of x equals -1 times x minus 5 times x plus 1. Okay, so obviously it's going to open down. A equals -1. What makes this equal to 0? So if I set y equal to 0 or f of x equals to 0, then I know either x minus 5 is 0, so I'm going to have x equals 5, or x plus 1 is 0, which means that x equals -1. So there we go. It's going to open down. I'm going to have these two x-intercepts, x equals 5 and x equals -1. There they are. Where is the axis of symmetry going to be? Well, you might guess it goes right in the middle, so it's going to be 3 spaces away from the 5 and 3 spaces away from the -1. Right there in the middle of the two x-intercepts. So here we go. Our axis of symmetry is x equals 2. So what are we going to do for the vertex? Well, we just have to plug in that x value. So wherever we see x, we plug in a 2. I've got 2 minus 5 times 2 plus 1, and then times -1. All right, and if I plug into my formula, I see 2, 9. So I'm going to plot that on my graph, right? Here's one of my x-intercepts. My other x-intercept is over here. Let's look at how that graph looks. Okay, now I've got my vertex right here at 2, 9, my x-intercepts like I had before. The other thing that I put on this graph is the y-intercept. And all I did for that was plug in 0. Just like vertex form, we can plug in 0 to get the y-intercept. So ours is 0, 5. We're going to do the same thing like we did before. There should be a symmetric point right here on this parabola. And there we go. There it is. And now this opens down. We already knew that. We already said that because of the a value. So go ahead and sketch it. This is really a nice form to have because often we care about these x-intercepts. They're the solution to whatever problem we're trying to solve. We'll come back to that more when we do some more application problems. Okay, so your practice work for today is on Khan Academy. You have 3 problem sets. And they say do Thursday, but you should do them today while it's all fresh in your head and you want to practice what you've taken notes on. We're going to look at some of these problems together just so you can see how they work. So here I've got the parabola's intro, I think, is going to be pretty straightforward for you. Let's just do a couple of problems together of graphing in factored form. So here's a factored form problem. I can tell that my x-intercepts are going to be -2, because if I set this factor equal to 0, I've got x equals -2, and -6. So I'm going to take this green point right here, and I'm going to put it over here on -6. But then I can't move this one to the other x-intercept. That doesn't really work. It wants this point to be the vertex. So just imagine if these are my two x-intercepts, -2 and -6, the vertex is going to have to be at -4 somewhere. Okay, then I might have to do a little scratch work because I don't know exactly where. So if I plug in -4 for my x value, then I'll have 2 times -4 plus 2 times -4 plus 6. So that's going to give me 2 times -2 times +2. And that gives me -8. So my vertex, I'm going to have to pull all the way down here to -8. And now let me think about that. this is opening up, that seems correct because I can tell that this A value is a 2. So it should open up. All right, great. And I'll check. And it says great. Okay, so let's just look at one of the problems from vertex form just to get the idea here. Awesome. What's the vertex going to be? Well, I can see that x equals negative 1, x equals 1 is going to be the axis of symmetry. So I'm going to move this over to x equals 1. And I know that my vertex is going to be 1, negative 4. Great, so I'm going to just move that down to negative 4. And then this other point, how could I find it? Well, I could plug in 0 and find the y-intercept. That might be the easiest way to do it. Plugging in 0, here I get negative 2 times 1 minus 4. And that gives me negative 6. So this is going to have to be something that opens down. My A value is negative, so that seems right. Let me just go ahead and check. Great. All right, so you've got those practices to do. Once you finish those, and I think that they will be pretty quick, but if you get stuck at all, Khan Academy has great videos. So you'll be able to go back and get extra help on anything that is confusing. 2 optional things to do, because for some of you that will go quite quickly. From before break, we had a marble slide that maybe you didn't finish, and there's that code to play with. Something that might keep your brain activated just on other things to keep your creative problem solving going is the daily problems on brilliant.org. So I put a link in here. You won't be able to click on it on the video, but that link is also on your daily agenda for today, and you can probably just search it. All right, good luck and have fun. Thanks.